Intro Algebra Lesson 1-5B, a mathematical model. So we've been dealing with expressions, we've been dealing with equations and inequalities. Now we would like to take them and apply them to real-life situations. We've had a number of formulas that actually can be used for those real-life situations. The mathematical model is a way of helping us to express that problem in an algebraic way, a mathematical way. Whether that be an expression, equation, or an inequality, but it must represent the real-life situation. All the problems that we did with simple interest, distance and rate time, anything for surface area, volume, those are all real-life applicable scenarios. So the model itself will start as follows. The first thing we will do is we will write the verbal model. Writing a verbal model is what it would be in words. For example, maybe we were going to say that area is equal to length times width. This would be an example of a verbal model. It's been done in words. That's the verbal model. But we don't want to stay at words. We want to continue from there. So we assign labels. Labels are values. It's something that we know. If we know the area, we'll stick the area in here. If we know the length, we stick the length in. If we know the width, we'll put the width in. If we know something, we put it in. If we don't know something, we have to put a place filler in, and that's where our variables come from. So maybe we know the area is equal to 40 inches squared. And maybe we know the width is equal to 8 inches. But what we don't know is the length. And because we don't know the length, we'll put L in for that value. We continue and we write the algebraic model. Simply fill in these values where they go. In this case we would say 40 inches squared is equal to, we don't know the length, but we know the width is 8 inches. So we went from words, which is the algebraic's verbal model. We assigned values or labels. Stuff we know we'll be able to plug in. Stuff we don't know we use a variable for, and we write the algebraic model. From that point, it's simply asking ourselves, what would we multiply 8 by to create 40? And the answer would be 5. So the length would have to be 5 inches. So let's see if we can do this on a couple examples. You and a friend buy some CDs that are on sale for $6 a piece. The total bill for all the CDs was $77.76, which included the tax of $5.76. Write an equation, so we know we're dealing with an equation, and solve for how many CDs you bought. That's what we're looking for. So a verbal model. Doing this in words, would it be fair to say the cost? We have the cost of $6 per CD. We could use D for discs if we want, or C, and just whatever you'd like. All right. So we know that our cost is 6. We don't know number of CDs. That's an unknown, so we'll call it D for discs. We do know the total. The total is equal to the tax plus the CDs. And we know that equals $77.76. And we know the tax is equal to $5.76. Now, if we want to think about this in terms of a verbal model, all I've done is pulled out the important pieces of information. A lot of people get bogged down with story problems because they don't look for what's important. What's the key points of the problem? We know what our total is. We know what the tax is, but we don't know what the CDs are. But we know that if we take $6 and we multiply it by the number of CDs and we add the tax, we should get our total cost. So this is the verbal model. Now we're going to take the values and see if we can sub them in for what we do and don't know, and we can go from there. We don't know the number of CDs, so we said we're calling that D. So that's now 6 times D. If we bought 1 CD, it'd be 1 times 6, $6. If we bought 5 CDs, it'd be 5 times 6, $30. This represents the amount of money spent on CDs. Plus the tax is $5.76. And we know that equals the grand total of $77.76. So we should be able to solve from here. Now, we don't want the price of 6 times whatever discs to equal this value, because this value includes the tax. So let's go ahead and get rid of the tax. If we get rid of the tax, we are now left with, not this over here anymore, we're getting rid of it, 6 discs is equal to the cost of $72. Well, if you multiply 6 times 10, you're at 60. So you know you're getting close. 6 times 11 is 66 discs. I mean $66. So 6 times 12 discs would be exactly 72. So 1 disc is equal to 12. I'm sorry, 12, the amount, not $12, but 1 disc. We know there's 6. We bought 12 discs. 12 discs. Forgot that represents money. The question up here says, how many CDs did we buy? We bought 12 discs. Check it and make sure. If you actually buy 12 discs, 12 times 6, you can do as a 10 and a 2. 10 times 6 is 60, 2 times 6 is 12. 60 and 12 add together to make $72. 72 plus a 576 will be $77.76. So that seems like a reasonable answer. Another problem. 8 friends went to dinner. The waiter gave them a bill for $130. At the register, a tax and tip of $30 was added onto the bill. Write an equation and solve for how much each person should pay, as if they were equal share. We're not going to go through and who bought what. We're just going to take the grand total and see what each one of them should pay. So that we have the bill plus the tax should get divided by the 8 people to equal their per person cost. We have some of these values. We've got the bill of $130. We have the tax and tip of $30. And we know that there are 8 people. So we can substitute that in. The bill is $130. The tax is $30. We're going to divide that value by 8. When we add stuff inside parentheses first, we get 160 divided by 8 equals 20. We would expect each person to pay $20, and that will cover the meal and the tax and the tip together. So verbally assigning variables and then solving. A salesperson drives at a speed of 50 miles per hour. The moment I start hearing 50 miles per hour, I'm probably going to start thinking, maybe there's some relationship to this. Maybe not, but it's a pretty good indicator that I'm dealing with speed, which is rate. When she is 170 miles from her destination, she remembers she has a meeting in 3 hours. Ooh, okay. So we've got all kinds of things going on here. We've got some time, we've got some distance, we've got some speed. See where this takes us. At the current speed, if she stays at 50 miles an hour, will she have time? Will she be on time for the meeting? Well, let's see. At the current speed of 50 miles an hour, she's got a distance of 175 miles. So the rate is 50, and the time we don't know. We're going to solve for that. So if we were to take 175 and divide it by 50, it should give us the time. Well, let's count by 50s. 50, 100, 150. 150 is not going to be 175. It's a little short. So we have to drive more than 3 hours. In fact, we've got to drive 3.5 hours. So the question is, does she have enough time at the current speed? No. She does not have enough time. She's going to miss the meeting by a half an hour if she stays at 50 miles per hour. But At what minimum speed must she travel from this point on to make the meeting on time? She still has to travel the 175 miles. We just don't know what speed, because it says right here, at what minimum speed. But we know the time is 3. We can now say, okay, what's 175 divided by the 3? And 3 will go into 1? No, but 3 goes into 17 5 times. 5 times 3 is 15. Do the subtraction, left with a 2, bring the 5 down. 3 goes into 25 8 times. 8 times 3 is 24. That means we have 1 left over. And if you want to bring in a decimal, come straight down, and we end up with a decimal right here. That's a 0. 3 goes into 10 exactly 3 times with 1 left over. Oops, 9. And what you'll find is that you're going to repeat this over and over again. Bring down another 0 and you're right back at a 10. So 58.3, the bar over it, miles per hour, is the speed that she must go if she would like to make the meeting on time. So she'll probably make it 59 or 60 miles an hour. Hopefully she's on a freeway where that's acceptable speed, and she'll make it a little bit early, maybe have enough time to use the restroom before the meeting. But given the circumstances that she has right now, if she stays at 50 miles an hour, she'll never make it.